In this example, we're going to learn about calculating the median from raw data. The median is a value that falls right in the middle of the distribution, such that half the cases in the distribution have a value less than that number, and half the cases in the distribution have a value greater than that number. I've taken a sample of 25 individuals from the 2012 General Social Survey, and we're looking at the responses to the question about how many children they have. I've gone ahead and taken the first step of calculating the median from raw data, and I've sorted the data from low to high. So you can see it goes from all the zeros and the 1 and the 2, 3, 4, and 5. There were no cases in this sample of people with 5, 6, 7, or 8 or more children. Because I have an odd number of cases, it's pretty easy once I've sorted the data to calculate the median. I simply count down to the middle case, which in this case is number 13. And then I read across and see the value of respondent number 13, and they had a value of 2. That's my median, or my 50th percentile. Some people might also call this the second quartile. And that's it, and that's the easiest way to calculate the median from raw data. If we'd had an even number of cases, we wouldn't have a case like number 13 that falls exactly in the middle. We'd have 2 cases. And so to calculate or estimate the median, we would take the average of their 2 values and call that the median. I can calculate other percentiles based on this kind of layout as well. And the 2 different kinds of percentiles we might be interested in are the 25th and 75th percentile, or the 1st and 3rd quartiles respectively. To do that, I'm going to take the bottom half of this distribution. Well, I know that the middle goes from cases 1 to case 13. So I'm going to look at just that bottom half, 1 through 13, and find the middle case of that bottom half, and then look at the value for that middle case. That's my 25th percentile. And then I repeat that process for the upper half of the distribution. So the upper half of the distribution extends from case 13 to case 25. And looking just at those cases, I'm going to find the median, that is the halfway point from case 13 to case 25, and then read the value, and that's my 75th percentile. As long as you can sort the data and find that middle case, the median is quite easy to calculate from raw data. Here we have a bit more complicated calculation of the median. We've got data that have already been put into a table or a grouped frequency distribution. In this example, I'm using people's ages from the 2012 General Social Survey. And they're grouped in intervals where the bottom interval is 18 to 19 years old, and then 20 to 29 years old, 30 to 39 years old, and so forth. Basically, each of those intervals, except the bottom one and the top one, are 10 years wide. The top interval is said to be top-coded. I've labeled it as 18 to 89, but hopefully you already know from the General Social Survey that it's 89 or older. In this case, 80 or older. And the bottom interval isn't 10 wide. I certainly could have labeled it 10 to 19, but nobody under the age of 18 is included in the General Social Survey, and so I've gone and more realistically labeled it 18 to 19. Let's look at the formula used to calculate the median from grouped data. This formula can also be used to calculate any percentile we're interested in, and all we have to do is shift the p sub I in that formula to the percentile that we're interested in. In this case, we're using a p sub I of equal to 0.5 so that we're calculating the median. Let's look at all the pieces here and then see if we can find the numbers in the table. Well, we know that we're going to have p sub 50 is going to be equal to the lower true limit of the interval that contains the percentile we're interested in. I like to use that cumulative percentage distribution on the right-hand side of the table, and I find the first interval that contains over 50% of the cases. That interval happens to be between 40 and 49 years old. So somewhere between 40 and 49 years old lies the 50th percentile, or the median. And the lower true limit of that interval is 39.5. So there's our L sub p. And I'm going to add to this the remainder. Now, p sub I is the percentile we're interested in expressed as a fraction. So I'm going to list that as 0.5, and it's multiplied by n, or the total number of cases, which I'm reading off the table is 1,969. And I'm going to subtract from that C sub p, which is the cumulative frequency up to the interval, but not containing the interval that has the median in it. So I have to go ahead and add up 32, 299, 389. That is to say, the interval that contains the median is 40 to 49. I need the sum of all the cases below that interval. That's the 30 to 39-year-olds, 20 to 29-year-olds, and 18 to 19-year-olds. And adding these up, I get 720. So I'm just going to go ahead and pop 720 in there and keep working. F sub p is the frequency or number of cases in the interval that contains the median. So again, the median interval is 40 to 49. The number of cases is 357. And then I take this whole quantity and I multiply it by the interval width, which is mostly 10 years wide. To solve this problem, you could certainly use a spreadsheet. I'm going to go ahead and use a Windows calculator. I'm going to solve this problem starting with what's inside the parentheses and work my way outwards. And I'm going to take this step by step to make certain I get the order of operations correct. 0.5 times 1,969 minus 720 divided by 357, which tells me I need to go 0.74 of the distance between 40 and 49. My interval is 10 units wide, which means I have to move 7.4 years, and I start at 39.5 years. So my median is approximately 47 years old. And I'll just add that in here. And that's how you can solve this particular problem. Remember, by changing this value p sub I, you can calculate from group data any percentile that you're interested in.